All right, today we're tackling a real logical head-scratcher, a mystery that has stumped some of the greatest minds for decades. We're about to crack open the quantifier's secret.
So let's just jump right in. I mean, think about words like all or some or there exists. They seem pretty basic, right? We use them all the time without a second thought. But what if I told you that hiding inside these simple words is a seriously deep puzzle? What's the big deal with them anyway? Well, get this. They're actually the unsung workhorses of logic. And for the longest time, nobody could quite figure out what they really were. It was this nagging puzzle that just wouldn't give up its secrets, challenging logicians for years and years. To get to the bottom of this, we've got to open the case file on what I'm calling the quantifier's double life. Okay, so in the world of formal logic, these words have a proper name: first-order quantifiers. You've probably seen the symbols, that upside-down A for all, or the backwards E for there exists. Their whole job is to tell you how many things a statement is about. Are we talking about all the things, or just some of them? So, what was the big holdup? The main issue was that for a very long time, logicians found the definitions they had to be, and this is a direct quote, unsatisfactory. They just couldn't nail down a clear blueprint for what these things are and what they do, which left everything frustratingly vague. And this vagueness didn't just create one problem. Oh no, it split into two completely separate and really tricky puzzles that both needed solving. Let's dive into this tale of two mysteries. On one hand, you've got the syntactic mystery. This is the how it works part. What's its job description in a sentence? What does it plug into? And on the other hand, you have the ontological mystery. This is the what it is part. What kind of abstract thing is a quantifier, really? It's like looking at a gear. The syntactic mystery is about which other gears it connects to. The ontological mystery is about what the gear itself is actually made of. For decades, these two puzzles were just separate. It was a huge roadblock. But then, a breakthrough clue appeared, a kind of master key that could unlock both doors at once. It's called the compatibility principle. This brilliant insight comes to us from the logician Roman Cusco. He proposed that the whole solution was hiding in plain sight, based on what he called the principle of categorical compatibility. And this, right here, was the turning point that changed everything. So what on earth is this principle? Well, think of it this way. You can't shove a square peg in a round hole, right? This principle is basically that, but for logic. It's a rule that says the shape of a logical piece, its syntax or structure, has to perfectly match the job it's designed to do, its semantics or meaning. Structure has to match function, period. This idea, which built on the incredible work of the great Gottlob Frege, finally gave us the framework we needed to crack the case wide open. Okay, so now we have our master key, this compatibility principle. Let's go after that first mystery, the syntactic puzzle. The solution is actually surprisingly slick. Structurally, a quantifier isn't just one single thing. It's more like a special connector that has two places to plug things in. The fancy-pants term for it is a two-argument functor function, but don't worry about the jargon. All it really means is that it has a very specific two-part job. Check this out. Here's exactly how it works. The quantifier is like our little machine. First, you feed it argument number 1, the variable it's going to affect, like the x in an equation. Then you feed it argument number 2, the sentence or the scope that it applies to. The quantifier's whole purpose is to bind that variable to that scope, and bam, you've created a complete logical statement. So we've nailed its structure, we know how it's built, but what does it actually mean? It's time to use our key to unlock the ontological code. First, a key term you need to know, denotation. Sounds complicated, but it's super simple. It's just what a symbol refers to. The denotation of the symbol 5 is, well, the number 5. So the denotation of a quantifier is the logical thing that it actually is. And here is the big reveal. The ontological solution is that a quantifier's denotation is a binary function, a function that takes two inputs to produce an output. Now wait a minute. Does that sound familiar? A connector with two inputs for its structure, and a function with two inputs for its meaning. It's a perfect match. It's just a beautiful moment of logical harmony. And what's really brilliant is that this solution works no matter how you look at meaning. Whether you're in a simple true or false world or a much more complex, context-heavy one, this definition of a quantifier as a two-input function holds up. It's a seriously robust solution.
So the crucial takeaway is this. The two-part structure from the syntactic mystery lines up perfectly with the two-input function from the ontological mystery. Structure and meaning are in perfect harmony. The compatibility principle holds, and the case of the quantifier's double life is officially closed. Now, I know this can all feel a little bit out there, so to make it crystal clear, let's wrap this all up with a powerful analogy to seal the deal, the plumbing analogy. Okay, so think of a quantifier as a really specific, complex plumbing fixture. The two arguments it takes, the variable and the scope, are like two different pipes it needs to connect. The syntactic solution gives us the fixture's design. It's a two-part adapter. And the ontological solution gives us its function, what it actually does with whatever is flowing through those two pipes. So when you boil it all down, successfully defining a quantifier was like creating the perfect engineering blueprint. A blueprint that doesn't just describe the precise shape and structure of the part, but also explains exactly what its job is in the whole system. One couldn't work without the other. And that brings us to one final big thought. This isn't just some dusty old philosophical problem. If we can define the fundamental pieces of logic and language with this kind of pinpoint precision, what does that unlock for the future? How could this deep, rigorous understanding of meaning and structure revolutionize the way machines understand and process our language? The secret of the quantifier might just be a key to the future of AI.